Hello everyone, I am Shubham and this is our presentation for our mini project for our course Wireless Sensor Networks. So the title of our project is Smart Dustbin System and the team members are Manya Mehrotra, Tanay Gupta, Shubham Kumar Singh and Aryat Dangwal. So let's move on with it. So coming to the problem statement, the biggest problem statement for our project is the inefficient waste management. So many times what happens is overflowing bins lead to hygienic issues and public inconvenience. Waste collection is often inefficient and costly, and there is no real-time monitoring for bin fill levels in most cities. Now, this can be scaled down to small localities or institutions and organizations, or it can also be viewed as a citywide problem. So, whenever there is no way of tracking if any dustbin in a locality is fill, filled up or it is empty, there is space or not. So, there are scheduled. Some places may require more often picking up of waste. Some places may not require that often. So that is something which is a very big problem nowadays. Now, our proposed solution is smart dustbin. IoT-enabled smart dustbins with sensors, wireless sensor network for multiple bin monitoring, and then there's a dual UI, Blink mobile app, or we can use ThinkSpeak dashboard. The Blink mobile app, it can be directly linked to your dustbin in your locality or your house or your office or your city. And we can also use the ThinkSpeak dashboard, which will send you a notification immediately in case your dustbin is overflowing or your dustbin is empty or not. You can always check the garbage levels in your dustbin. This solution transforms reactive waste collection into a proactive data-driven operation. What this means is, right now, what happens whenever your dustbin is full, that time you go and empty out the dustbin, or you call the municipality to come and then clean up the dustbin. What our solution provides you is uh, instead of a reactive solution, it gives you a proactive solution. So you can know beforehand that when your dustbin is about to get filled or it's currently filled or not, and accordingly you can manage your waste collection. Coming to the system architecture overview, we are using the IR sensors for detecting the human approach. So we have also automated the lid opening and closing, preventing a contactless experience, which is very helpful in unhygienic situations and prevents the spreading of diseases. Fill level measurement. This is being used done by an ultrasonic sensor on the lid of the dustbin. It senses and tells you to what depth of the dustbin the garbage is filled up. Data processing and transmission. We are using the ESP8266 for processing collected data and sending it to the cloud via Wi-Fi. We are using real-time monitoring via any UI, Blink, or ThinkSpeak dashboard. And then we also have a historical data analysis, which stores the historical data for analysis and insights. The key hardware components we have used are ESP8266 Node MCU. Basically, Node MCU is a kit board designed around ESP8266, which is Wi-Fi enabled to collect and transfer data over to cloud for processing. Then we have the ultrasonic sensor, which is HCSR04 for measuring the distance of the weight from the lid. Then we have the IR sensor, which detects the human presence. Now, there is the reason which for which we are using IR sensor is because IR sensor is much faster compared to ultrasonic sensors, and also it uses less power. So, in the long run, the ultimate goal of WSN systems is to make sure there is energy efficiency. So, this is what we're aiming for. Then there's a servo motor which controls the automatic opening and closing of the bin's lid. Then there are buzzers or LEDs for providing audio and visual alerts for notifications, such as when the full is empty or filled up. So whenever the bin is filled up, it will display you a red LED. And if you go and try to open up the dustbin, it will give you a buzzer sound, which will tell you that the bin is currently filled up. And there is this power supply unit, which provides power to all the components. Now, detailed working and principle. First of all, whenever the human presence is detected, the lid is activated. The IR sensor detects the human presence, prompting the microcontroller to actuate the servo motor and automatically open the bin's lid for contactless disposal. Then there is this ultrasonic base level measurement. The ultrasonic sensor on the lid of the dustbin emits sound waves and measures the time for their return. This is how it is able to calculate the distance of the waste from the surface. Fill level percentage calculation. Again, the waste level which has been detected by the ultrasonic sensor is used to calculate the precise fill level percentage, which is 0 to 100%. 0% meaning that the dustbin is fully empty, and 100% meaning that the full garbage is full. Cloud data transmission and visualization. The ESP8266 microcontroller wirelessly transmits the calculated fill percentage along with the bin ID and timestamp to cloud platforms. This enables us to keep a track of all the dustbins. So, for example, if there's an organization which is keeping a track of all the garbage bins in their offices, then this system helps them to track each bin with their bin ID along with the timestamp. So the waste disposal and collection can be scheduled accordingly. Automated alerts and notifications. Again, this is achieved by the UI. Software and cloud platform. So basically, there are two ways in which we can uh, see the output from the sensors. First is the Blink UI, which is a mobile friendly user interface for live status. Another one is the ThinkSpeak, which is for dashboarding on the laptops and computers. And obviously, there's this Arduino IDE, which we are using for programming the ESP8266. It also displays the outputs in its serial monitor. So now the WSN integration. Coming to the network topology, how a network and connecting all the different bins which act as different separate nodes. So sensor nodes, each waste bin becomes a smart sensor node. So basically each of the bin in any system, it's representing a node independently monitoring waste levels and environmental parameters. So here all the sensors are edge based and each bin is acting as a single individual node. These nodes operate autonomously to collect critical data. Central cloud platform, so all the data from all the different nodes, which represent each bin, is wirelessly transmitted via ESP8266 to a central cloud platform. This platform aggregates and processes information for real-time monitoring and analysis. Then there comes the scalability. The modular design allows the system to scale effortlessly to any number of waste bins in diverse locations. So it can be scaled up or down any number of bins. There will be no issues. This ensures efficient waste management across various environments. Finally, coming to the UI demo, as I told, we can either use the Blink app for visualization on your mobile phones. So you can always keep a track of your bin waste levels on the go, or you can use the ThinkSpeak dashboards, which provides robust data visualization tools. This will be more useful for big organizations or the municipality if they decide to keep track of all the bins. Now, coming to the broader applications and impact, it can be used in smart cities. So there will be various number of public dustbins, garbage bins, and smart cities, and the automatic opening and closing of lid can effectively help reduce the transmission and spreading of diseases, as well as the collection of garbage. University campuses, it's very crowded everywhere, so it can be used for that also. It can be used in shopping malls as well as public events and gatherings. Future scope, solar powered operation. So as I told, we had a separate power unit for this project, but when implementing it on a larger scale, we can implement a solar panels or outdoor bins for self-sustained energy, reducing reliance on grid power. Weight sensors, which can be integrated for advanced weight sensors for highly accurate real-time fill level detection, optimizing collection routes. So we can put a weight sensor below each bin so that to make sure that the dustbin is not overloaded. Then there can be a GPS integration which can help track bins for precise tracking and management in dynamic environments. And then finally, AI-based waste sorting, which can also be integrated inside the bin for automated and precise waste sorting within bins, enhancing recycling efficiency. Finally, coming to the conclusion of this project enables enhanced waste management, which improves waste management efficiency through intelligent collection and routing. This integrates modern technologies in IoT and WSN with integration to cloud platforms to deliver tangible real-world impact in urban environments. Finally, comprehensive user interface. A dual UI ensures both real-time live monitoring capabilities and detailed analysis insights for optimized waste collections. Thank you so much. That is it for our presentation. Now we'll move on to the working and code of our project. So this is the code of of our project. Here I'll be discussing the working of our project. So as you can see, these are the pins of all the sensors. There's a IR pin for the IR sensor, uh, trigger and echo pin for the ultrasonic sensor. There are two LEDs, green LED for when the dustbin is available, and red LED for when the dustbin is full. And then there's a pin for the servo signal. Now here, as we can see, these are the two angles for the opening and closing of the lid for the servo motor. Now, the hand detected distance is 10, which is used by the IR sensor. So any person or hand comes within the distance of 10 centimeters, the dustbin will open up. And then if the dustbin is full with garbage below 5 centimeters, the dustbin will not open. That means the dustbin will indicate that it's full right now. Now, the lid close delay is 3 seconds. This can easily be modified here. And then open wait timeout is 10 seconds for safety measures. And then serial update interval is zero point 0.5 seconds. That is how often to print the status in the serial monitor. And here, as you can see, we are setting up all the sensors and motors, and we are assigning all the pins, lid servo attached, and right. And this is all the code for running the loop. Serial printing, smart dustbin initiated, IR resting state, high or low. And then there's this loop in which get distance. This is being used to get the distance from the ultrasonic sensor. Then update LEDs according to the distance. And this is for the IR sensor, raw digital read. This is for the use for the input from the IR sensor. And if presence is detected, then the lid will open up. Here, as we can see, it will also display the hand detected printout in the serial monitor. And now these are the some of the helper functions. So, for example, as you can see, if the distance is greater than zero and the bin is full, then the LED will be displayed as red, and the test lid will not open up. And these are all the displaying part in the serial monitor. So for when the bin is full or available, when the IR is resting high or low, and the time for which the project has been up. This is for displaying the servo motor status, if the lid is open or closed, and here waiting for the timeout time. And these are all the lid closing and opening outputs. So now we'll jump to the running of the project.
So here, as we can see, this is the IR sensor which detects the presence of a human. So whenever a hand approaches or a person approaches to the IR sensor, if they're within 5 or 10 centimeters of the dustbin, the lid, it will sense and send a message to the microcontroller, which will enable the servo motor to open the lid. Now here, as you can see, this is the ultrasonic sensor which detects the presence of garbage and the depth level of the dustbin. So whenever there is garbage inside, it will tell you the how much of the bin is empty or full. And whenever the garbage fills up, it will detect and tell you that the garbage that the bin is full and the lid won't open up. Here, as you can see, we have attached the power source and the microcontroller behind the dustbin, and this is the entire overview of our dustbin.
So here, as we can see, right now we are in the Arduino IDE environment. Here, as we can see, it is showing the distance as 21 centimeter, which is basically the depth of the dustbin, and it is showing the bin as available. That means there is enough space in the bin right now. And IR resting position is low. That means there is no human detected right now. It's also showing you the uptime. So now, if a human approaches the dustbin, as you can see, it opens the lid, and it is also showing you that the user is present right now. The distance which is being shown here is the distance of the hand from the ultrasonic sensor as the user is present. So now as I remove the hand, as you can see, the lid has been closed. And again, it's showing that the distance 21 centimeter and the bin is available. So now if I throw something into the dustbin, as you can see, I opened the lid and now I have thrown a garbage into the dustbin. So now as you can see, there is garbage inside the dustbin and it is showing that the bin is full. Resting position is showing low because no one is approaching the dustbin yet, and the bin is full. So now, if I try approaching the dustbin, as you can see, my hand is in front of the air sensor right now, but it is showing that hand detected, but bin is full, lid blocked, will not open. So this prevents the lid from opening and the garbage from overflowing from the dustbin.